Alright, welcome back guys. This is Ivan from Brainy-Bits.com. Today we're going to do something that I find is pretty cool. It's the good old countdown timer that we see in so many movies and TV series like Mission Impossible or 24 and stuff like that. They're really cool looking. The way we're going to do it today, we're going to use an 8-digit display module that we have here. As a bonus, we're going to put some sound when it counts down, so we're going to hear the ticks, and also at the end, when the countdown reaches 0, it will sound like an alarm or something to make it more interesting. So this is a passive module, buzzer module, and the way these works is that you can make your own frequency on these by turning them on and off rapidly. So we'll see that in the code. The rotary encoder here, I'm just using it because it's acting as a switch, because this rotary encoder, when you press on it, it's a switch. So, but what I would use here, maybe an arcade button, you know, a big button to start the countdown going. The way we're going to do it, we're going to use an actual number. We're not going to use a time library or a real-time clock module. What we're going to do, we're going to use, let's say we start with a number 100,000, and 100,000 we're going to count down from that. So 100,000 will become 99,999 and so on. The trick is, though, I didn't want just to show a number counting down. I wanted to show like it was an actual hour, minutes, time format. And the way I did it is that, let's say these two numbers are representing minutes. And let's say it's counting down. So at some point, these two numbers will become 99. And 99 minutes doesn't really exist. It should be 59 minutes. So the way I managed to do it is that I subtract 40 from 99. And that gives us 59. And I do that in different places, so we're transforming an integer, which is the number counting down, to a string, and then we can search inside that string where the nines are and if they need to be replaced. It's not complicated, but it's just kind of confusing sometimes, and I was confused when I was actually writing it. So the connections are fairly easy. This guy basically is like 2 4-digits, so it has one more pin. And they're going to pin 12, 11, and 10. This switch basically goes from signal pin, let's say 5, and I'm connecting to ground, so when I press on it, it becomes low. And the buzzer, the same thing, only one pin is needed. It's connecting to pin number 3. And we're using the breadboard just to split the 5 volts and ground to all this stuff here. Now also, I mean, if you want to see all the connections better, go to our website, brainy-bits.com/tutorials. You'll find the link for this tutorial, and we have a schematic picture there which shows you all the connections. And also, you can download the code, get more information, and see the parts that we use in this tutorial. So we're going to cut here. I'm going to go look at the code. I'm going to try, like I said, explain it as best as I can, and then we'll come back and we'll start our little countdown timer right here. So let's go take a look at the code. Alright, so here we are in the code. Like I said in the introduction, the code, you know, it looks complicated. There is a lot of stuff in here. You have to take it slow, you know, line by line to understand the logic behind it. So just take your time and read through it. I'm going to explain a little bit what's going on here. So we're going to start at the top. We're defining the pins. So where each pin is connected. This left and right, this is an option that we'll see lower in the code to justify your numbers to the left or to the right of the display as they're counting down. I believe we're using right in ours, so I'll show you where that is. The buzz trigger, because we want to the buzzer to trigger every second to do that ticking sound. I'm putting it at 9. 9 seems to be a good value to follow every second. Keep in mind, this tutorial countdown timer is not super accurate. I mean, we're not using a real-time clock or anything. It is accurate, but you know, it wanders a little bit, so it's mostly for show and fun. So keep that in mind. My string, we use that variable to put the transform the integer value of the counter into a string, so we can then look for those nines that I was talking about, so we can transform them later into subtracting some value. So we get, instead of 99, we would get 59, which is more a minute value than 99. This value, well, basically value equals this number. So we break down the number this way. So the two first numbers are hours, minutes, and the last three are seconds, because the last one here is tenths of a second. So that's the way this is broken down. The code will work up to 24 hours. You can't put 48 because we didn't, well, I guess you could put 48, but we tested it up to 24 hours and lower than that. Now the rest of the code here, we're basically describing which segment we're activating. So this code you don't need to touch. This one here is just drawing the segments for the particular numbers up to the dot and blank if you want to blank one of the display. So we don't need to touch any of that. That's the function here that actually shifts out the values inside the display. So that's fine too. There's nothing to change here. And as you can see here, there's two, if justify right and else if justify left, but you don't need to touch anything in here. So we'll go down to our code. So the setup, latch output, these are all output. The button we're putting input pull up because we want to use the pull up resistors inside the Uno. So we don't have to put an external resistor. Never had any problem with that, so I like to use these. Digital write high to wake up the display. We're putting the buzzer pin at low, so the buzzer is off at the start, and we're putting the button high because we will connect our button to ground, so we'll bring it to low when we press it. And just a little delay, you know, to let everything settle down. And here we go in our main loop. So at the beginning, we're waiting for the button press to start the countdown. So while the digital read pin button equals high, it is high because we put it high at the beginning, we're going to display the value. So this is the way you display the value, and that's this justification here. So if you want to justify to the left, you would put left here instead. And the value is the value that we defined at the top, which is 200,000, I believe. So we're just displaying the value, not doing anything else until we press the button. The button will go low, so then it continues. Now here, for value equals 1, so we start actually counting down. So the value is 200,000. As long as it's not equal to -1, we do value minus minus, meaning subtract 1 each time you do that loop. So it'll start. Now this for loop here, you can adjust the I equal x. So right now it's 9. If you put it like 2, I'll show you that when we go back to the breadboard. If you put it at 2, then the countdown will go a lot faster. So you can put it higher or lower to speed up or slow down the counter. Here, string my string equals string value. So we're transforming the counter, well, I shouldn't say integer, but it's an integer, to a string, because we want to do some manipulation on it after. And here's the due time offset. And this looks very small, but it took me a lot of time to actually figure it out so it would work for every value. And basically that's all this little piece of code does. It checks to see if there's 9s at specific position in the code, and it subtracts a value depending on where it finds it. So 999 minus this would equals 59,999, but then it finds 999 here, so it would subtract. So, you know, it's hard to explain how this works exactly. I kind of remember, but it's hard to explain it. Basically, when it finds some 9s in a specific place, it will subtract that amount to make it 59. But it does it in a loop, so it checks, starting at this character, check if you have these 9s in a row. If you do, subtract that, and then the same thing for these 9s. But anyway, it works. I could probably explain this better, but I'd rather you guys try it, and it's easier if you understand it on your own. Once we've done that, we actually, so we change the value. The value is not equals to number with all those 9s in it. Then we display the number, display the value. Now the rest of it, it's just the buzzer. So if the countdown is finished, we're sounding the alarm. So if the value is at 0, meaning the countdown is finished, we're doing these loops here, and that's how you do frequency sounds with these passive buzzers. Basically, you put it high for a number of seconds, put it low for a number of seconds, and you do it a number of times to create a sound. And then the other sound, you're going to do another type of delay, like 2 for this one. So you can play around with this. You can make your own sounds. I mean, the range is not huge, but you know, it's kind of cool. The rest of it here, basically, when the countdown is finished, we're putting all zeros on all digits, and then we're blanking it, so it goes full zeros off, full zero off with a delay. And we have our countdown tick sound. That's the one that's gonna do every second. So if buzz trigger equals 0, because we want to do it every second, we're gonna do the same frequency things that we did there to do that ticking sound. And when it equals 9, so we're always, once it's done it's gonna put it to equal 9. And then if the buzz is not equal to 0, it's gonna -1. So it's gonna go through this 9 times, and then it gets to 0, does the buzz, and then that's the way it works. So that's the code. It's a lot of code, but you know, it's not complicated, just confusing. And like I said, I was confused also when I wrote it. And basically this little part here was like this big at the beginning when I was trying to do it. And that's what's cool, is that once you figure it out, that's all the code you need basically to do what I was trying to do. So we're gonna stop and we're gonna upload the code to our Uno and go check out the result on the breadboard. So let's go have a look. All right, so here we are. We uploaded the code to our Uno. We're starting with the counter at 20 hours. So it's waiting. I actually got an arcade button, red button, to actually make it more real. So everything is ready to go. We uploaded the code, so our countdown timer is just waiting for us to press the button. So we're gonna start it. After that, I'm gonna upload different code so you can see the ending, and I'm gonna speed it up also by changing the value of the loop that we saw. So let's press the button and go. There you go. As you can see, we have 19 hours, 59 minutes, 50, counting down the seconds now, and the microseconds are there. And we got our buzzer going at the same time. So there you go. That seems to be working. Now I'm going to upload 10 seconds so we can see the ending. So let me upload that. There we go. It's uploading it. There we go. So the last one is tenths of a second and seconds. So we have 10 seconds on this one, like a good old 10-second countdown. So let's press the button. And there we go. We got our alert. We made the different frequency by turning it on and off and flashing the zeros. And then it'll go back to the original count. We're gonna upload the other one, which will be a little bit longer, a little bit faster, sorry. So let me put something like this, and let's speed it up. If I can find the value, there it is. So let's do this one instead. Let me upload the code right now. There we go, it's uploading. Now I changed the value to 2, so it'll count a lot faster. Yeah. So there you go, you could play around with this. Basically in the code you could say when there's 30 seconds left, you know, make the code go faster, because that seems to happen a lot in movies. There's a lot of things you can do with this. It's just the complicated part was getting the numbers to actually represent time. But we managed to do that, and I hope I explained it as best as I can so you guys could understand. So once again, guys, thanks for watching. Let me turn this guy off, at least the buzzer. Let me unplug the buzzer here. There we go. So like I always say, we try to do 2 tutorials a week. I know lately we've been doing 1 only. It's because these things, sometimes they take time. We have to write the code. Sometimes it's easier. Sometimes we have more time. We have the store also that we're taking care of, putting new products and description and all that. But we do our best, but we promise to do at least 1 every week. So if you want to be notified, you can subscribe to our YouTube channel if you're new. And well, that's it for today. So this guy's still counting down. So I'm not gonna wait until it reaches 0. So I'm gonna say goodbye to you guys, and I hope to see you guys real soon. Take care.